Welcome to Chapter 1, in which we will be talking about functions and graphs. Here you can see a lot of different types of ways to display functions, in a graph, in a table, a diagram, and here's my favorite, the function machine. In 1.1 we're going to review rectangular coordinate system and plotting points. We'll take a look at our calculator and make some graphs. So, first thing I'd like you to do is I'd like you to do the following in your notes. Please draw a coordinate plane, then label the following: the origin, the x-axis, the y-axis, and label quadrants 1, 2, 3, and 4. Then I'd like you to plot a point with an x-coordinate of -5 and a y-coordinate of 1, and then I'd like you to write the ordered pair for this point. So go ahead and pause this video, and then follow those directions, and then press play when you're ready to move on. Alright, so here is what your graph should kind of look like. Quadrants 1, 2, 3, 4. Origins right here at 0, 0. X-axis is the horizontal axis. Y-axis is the vertical axis. Here's a point at -5, 1, written as an ordered pair, like so. Alright, now let's talk about graphs. Here's an equation, y equals 4 minus x squared. Find a solution of this equation. So the solution is going to be a value for x and y that satisfies the equation. That means when you plug in a value for x and y, you make a true statement. So let's generate a few solutions. For example, if y is -3, that means y is equal to 4 minus -3 squared. And -3 squared is 9, so that's 4 minus 9, which is -5. So what that tells me is when x is -3, y is -5. And then that gives me the ordered pair, -3, -5. And then we can find more solutions. Plug in a -2. We get 4 minus -2 squared, and that would be 4 minus -2 squared is 4, and I get 0, and that would give me the coordinates -2, 0. So now go ahead and plug in a few more points. I'd like you to plug in -1, 0, 1, 2, and 3, and I'd like you to find the ordered pairs for those points. And again, go ahead and press pause, finish that up, and then press play when you're ready to check. Ta-da! So there are the points that you get when you plug those in. Now let's take a look at the graph. Now, this method of making a graph is just point plotting, which means we're just going to take the points that we know are solutions, plot them on a coordinate grid, and then connect them with a smooth curve. So, -3, -5 gets a point right there, -2, 0, -1, 3, 0, 4, 1, 3, 2, 0, and 3, -5. So I know all those points are on my graph, and now I connect them with a smooth curve. And put arrows at the ends because this graph does continue forever. Now let's take a look at your graphing calculator. So let's go ahead and type in y equals 4 minus x squared into our graphing calculator. So I've got it right there, y equals 4 minus x squared. Then go ahead and hit graph, and depending on what your Windows settings are right now, you may or may not see this screen. Let's talk about the window real quick. Right now I've got a viewing window of this. Now what does this notation mean? What do each one of those numbers mean? Well, here's what they mean. This is the x minimum, that's the minimum x value on the x-axis. Here's the x maximum value on the x-axis. This is the x scale. That means my tick marks on the x-axis are counting by ones. And then here I've got y minimum value on the y-axis, y maximum is the maximum value on the y-axis, and then my y scale on the y-axis. These tick marks are also counting by 1. If you go to your window settings, you will see those numbers right here. And that means if you were going to label your grid, that dash would be 10, and that would be -10, and then that would be -10, and that would be 10. The window button is right there. So you can see those numbers typed in, give you this graph. Now, we call this window like a standard window. There's even a special zoom button on your calculator. If you hit zoom and then select option 6, zoom standard, it will get you to a window that goes from -10 to 10 on both axes. So that's a good option when you change your window and want to go back to a typical window. I want to talk about a few different zoom options. So you can see I've got them here. One is zoom square. Don't know if this one's as popular for you, but if you hit zoom and select option 5, it actually will space out the tick marks the same distance on each axis, which actually will make your viewing window basically more square instead of rectangular. What that means is, like, for example, if you were going to graph a circle, on this grid it would actually look like a circle. On your standard window it would actually be stretched out horizontally because your physical screen on your calculator is just wider than it is tall. So this kind of fixes that. Zoom fit is one I see a lot of people use. I don't like it that much, but I thought I'd talk about it. Here, zoom fit is option 0. Basically, your calculator will just make up a window that it thinks might be good for the graph you're looking at. So you can see for this one, it kind of just tries to show you what it thinks are the important parts of the graph. Or it shows you the whole graph from -10 to 10. But if you look at the window here, it's kind of weird. It goes from -15 to 15, and then y minimum is down at -2 25. Here's one that earlier when I did zoom fit, I got these numbers. So I don't use that as much. One that you maybe haven't used that I want to show you is called zoom decimal. So I'm going to go back to my standard window first. And then I'll hit zoom, and then option 4 is zoom decimal. You might not think this is very useful. If you look at the graph, you don't get the top of it there. But what is nice is if you hit trace now and go to the right, you can see that this x value right there now goes up by 0.1 every step. So it is a good way to have your trace button give you values, incremental values that are a little more reasonable. You can see a few other options here that you can play around with. Zoom in, zoom out, I think you're familiar with. There are some other zoom integer that will make your trace button go by whole numbers. Here, this will make your trace button go by these fractions. So a lot of options there, and you can play around with them as you like. What's most important is that you understand how to change these yourself, and you understand what they all mean. Now let's look at our table setting. So I've got the equation typed in here. Go to your table setting, which is going to be above window. So if you press second window, you'll get to your table setting. This number right here, as it's labeled, is your starting value for your table. That's whatever you want your table to start at. This symbol means delta, or change in. You've probably used that in science. And so that's what it's changing by. Right now it's set to change by 1. So you can see my table starts at -3 and it changes by 1. That means this x value goes up by 1 each step. You can see that right here. This -3 will give you your starting value. This one will give you what it's going up by each step when you go to the table. Next, let's talk about x and y intercepts. So if we're identifying x and y intercepts on the graph, x-intercept would be the place where your line crosses your x-axis. So this one right here is your x-axis, and this one right here is your y-axis. So this one has an x-intercept right there and a y-intercept right there. So the x-intercept for this graph is -1, 2, -3. And the y-intercept for this one is 5. Now this one right here, where does it intersect the x-axis? There's the x-axis, and you can see that this blue line here will never intersect the x-axis. So it does not have any x-intercepts. Y-intercepts, though, it intercepts the x-axis or y-axis right there at 4. So it does have a y-intercept at 4. This one right here, where does this intersect the x-axis? Well, it intersects it right there at 0. So there is your x-intercept, 0. And then where does it intercept the y-axis? Well, it crosses it right there at the same point it crosses the x-axis. So this one has a y-intercept of 0 as well. Now let's talk about reading a graph a little bit. Here's a fun problem. At noon you begin to breathe. Which of these 4 options, this is multiple choice question here, which of these 4 do you think best models that situation? Take a second, press pause if you need to, and take a guess. Correct answer is A, because you begin to breathe in, which means the volume of air in your lungs needs to start by going up, and then when you breathe out, the volume goes down until you start breathing in again. Let's try another one. A little more to read here. You begin your bike ride by riding down a hill, then you ride up another hill, finally you ride along a level surface before coming to a stop. Pay attention to labels. The y-axis has speed as a label, so take a second, press pause if you need to make your choice. Correct answer is B. You start by riding down a hill. That means you're gaining speed. That means your speed is increasing as you ride down that hill. So there, the graph is going up. Then you ride up another hill, which means you will slow down. So your speed will go down. Then you bike along a level surface. So during that time, you should probably remain at around the same speed. And then you come to a stop, which means your speed decreases until you are fully stopped at 0. So, that's all I've got for 1-1. Go ahead and give that 1-1 homework a try. Good luck. Let me know if you have any questions.